All right, welcome back to the Engineering 255 Statics. This is the last video of the chapter 6. Chapter 6 is about structural analysis. Previously, we were looking at definition of the truss, which is a simple triangle structure with members that only have two ends will be connected. Um, Now, we also talk about two different methods to analyze the structural analysis, which are the method of the joint, that you use summation F at each one of the joint to find the force for each one of the member. The second method that we're looking at is called the method of the section. That is useful if you only just wanted to know some particular members, and the method of the section is the best way you cut through the members that you are interested, and you use the summation F and also summation of the moment to find a solution. And here we're going to look at a different structure which has the similar characteristics like truss, and you are going to use similar methods to solve the problem. So we're going to see some of the example and to show you what the idea is. And that member is what we call the friends and the machines. So objective is that if you have a friends or machine structure, how do you draw the free body diagram and to identify how they are connected and how to analyze those forces? And once you be able to draw the free body diagram, then let's see how we can determine the force acting at a joint and the support of the friend and the machine. So it's very similar to the previous one. Some of the application you can see we have this one here actually is a machine on the right hand side, just a small tool, but you can think about this tool is like a machine as well. For any kind of a machine, you can disassemble it into like smaller components, and each one of the joint, just like the joint in the truss. So here you start from the bottom at A with the joint at A connect to this vehicle, and this I guess this kind of a crawl goes up and goes to the right, and the C connect to the E, which is a hydraulic system, and this main friend is from C to D, and there's another friend, another hydraulic system from the F to the I, and so you just need to identify each one of the members in this structure. Same thing when you look at this tool at here. You have this piece here, the other piece here, and this slider thing here, it's more like a sliding pin, right? You allow it to move in this direction. You don't allow it to rotate. You don't allow it to move to the left and right. So this is what the structure looks like. So that's kind of make a picture to show the difference of these two. Actually, you don't really need to separate them into different kind of things. You just need to know each one of the member and how the force is applied to each one of the member. So this is an example of the friend that you have some members and with some smaller components. On the right hand side is more like a machine, and you separate the components in the machine into segments and how they're connected. So they say, well, if you have a friend, normally they are more like a stationary. The machine will have the moving parts, but when we are doing the design, we don't treat the moving part as the moving object. We treat it as the static object. That's what we are doing at here. We're doing a static analysis. And the step to analyze the friend or machine is very similar to the truss one. First, you're going to draw the free body diagram of the friend or the machine. So if we have this as an example, you're going to draw a free body diagram for the overall structure, and you need to find a supporting force. So the supporting force will be the pin at here, and another pin at here if you draw the overall. If you cut them into different members, then the B at here is another pin as well. However, because A and B is a two-force member, and the force will go along the A-B direction. Do you think BC is a two-force member? And the answer is not, because you have an external force here, so it's not going to be a BC member. It's not going to be a two-force member. So you cannot say, oh, the force is going to be horizontal. No, it's not going to be horizontal. If you use the method of the joint, this one, which is actually quite simple, you can use method of the joint. Once you find the supporting force here, and you know this force is going along this direction, you can simply just work on the top member here to find a solution. So when you have a clear picture of the member like this one here, you need to strategically to think about, are you going to use summation F equal to 0? Or are you going to use the summation moment at 0? In this example here, you have a three unknown. You have FAB, CY, and CX, which means you need three equations. If I wanted to solve this problem, I will probably first just by using the summation moment to find the FAB. When you do summation moment, I will choose the moment at the C point because the C point has two different forces. You can also select the point at here. However, it's not going to help you to find the FAB, right? Because if you select this point as the summation moment, FAB will create zero moment, which means the FAB is not going to be in your equation. So it's better that you choose point of C. When you choose point of C, you decompose the FAB into the X and Y component, and this X component is not going to give you any of the moment because it's along the line, which will be zero perpendicular distance away from this point. You only have the Y component that will generate a moment. So it will be a lot easier to solve this problem. Here's another example. Let's look at this example. This is a frame because this doesn't have like a moving part. You can see there's a two support at A, support at the C. If we just look at the support at A, now A is a pin, so you are going to have two different forces. However, AB, this one is a two-force member. So if we analyze this frame, and you can see this frame has a support at A, support at C, and AB is a two-force member, so the force of AB should go along this direction. B to C is not a two-force member because you have an external force 400 Newton applied to it, so you cannot simply assume the force will go from B to C. No, because it's not two-force member. So on the right-hand side, you can kind of see the simplified version of the structure of the BC. An angled force FAB, that direction is known and applied to the point B. And then you can collect all the rest of the information. You have external force 400 Newton on the top. You have 800 Newton meter at the left upper corner. You have the CX and CY applied to the point of C. And you simply just use summation F, summation F Y, summation moment. In this case, I probably will still use the CX and CY point as my summation moment, which will simplify my calculation. And you can find a solution by finding the summation moment. And that is the answer right here. So if you find out the FAB from the previous equation by finding summation moment of C equal to 0, Then you can find summation f of x, summation f of y. You can find cx and cy individually. And then you actually solve the problem. So this is the end of the chapter 6. So basically, I want you to know that in this chapter, either you are analyzing a trust or you analyze a friend, analyze a machine, it's all the same. You just need to draw a free body diagram of the overall pictures. Then you can find a supporting force. Once you find a supporting force, it depends on what the problem is asking. You can either use the method of the joint or use the method of the section to find a solution. And a lot of time you're gonna have the two force member. Just remember, two force member will simplify your question because the force will go along the member's direction, and that is the key point of this chapter. I hope that you understand all this material and work on the homework. And that is the chapter 6.